Welcome, math aficionados. This is Victoria, and I'd like to introduce you to Chapter 7. And specifically in this chapter, we'll cover Section 7.1 on radical expressions, 7.2 on radical exponents, 7.3, and also 7.7. And this video is about 7.1. When you are getting ready to prepare yourself for this homework, make sure that you go through and do lots of examples because there's a lot of things that you need to be well aware of, and the quiz is going to cover all of them. So here on page 434, you're going to see the definition of what the radical is. And so here I'm showing you a couple examples. The way that I like to think about it is when you have a radical, we're going to call the symbol here itself is called the radical symbol. And this number here that's sitting above the radical symbol, that's the index. And the number inside of the radical symbol is called the radicand. So if you're looking at these examples right here, we have a radical symbol with a 3, and that indicates it's a cube root, and the radicand inside is 125. So you could do a factor tree to break this down, but most of you may or may not know that this is really 5 times 5 times 5. If you multiply 5 by itself 3 times, you're going to get 125. And what I like to think is that when you're doing these, you're trying to find a triple. Since you have a cube here, you're trying to find something that's a triple inside of here. And so, of course, the triple for this one is going to be 5. Let me see if I can get my pen on the darker color. Is going to be 5. So the answer here for the cube root of 125 is going to be 5. Now, if we're looking at the cube root of negative 125, well, what do we do to find that? Well, that's, again, is a triple, and it's going to be a triple of a negative 5 times a negative 5 times a negative 5, because a negative times a negative gives us a positive, and then again, a negative times a positive will give us a negative. So we do, again, have a triple. And so the triple that we have here is going to be negative 5. Negative 5. And then this last one down here, you'll see this quite often as well, where the negative is sitting outside of the radical sign. And so what it's asking you to do is to find the cube root of 125 and then place a negative in front of it. So again, we've already decided that 125 is actually 5 cubed. So the cube root of 5 cubed is going to be 5, but we're going to place a negative in front of it, and we could easily write that as negative 5. So these are just examples of what the radical means and how to solve them. Back to our textbook. They spend a little bit of time talking about principal roots. And this is an important idea because every time you take, let's say, square roots, if you had a square root, if we were looking at 4, if we square 4, we get 16. And if we square negative 4, we get 16. So we're going to say that the principal square root is the positive root. So the principal square root is going to be the positive one. And this is also a root, but if they're asking for the principal, we're going to go with the positive root. And it becomes very, very critical when you're looking at these examples, is the index even or odd? How often in mathematics that is something that we look at when we're graphing, is the highest exponent even and odd? And here is another case where number theory, one of my favorite things, comes into play. And we do need to be careful about whether our index is even or odd. So I'm just saying beware, beware. If the index is even, then let's talk about the odd case first. When the index is odd and the number inside the radicand is negative, that's not a problem because we could have a negative times a negative times a negative. So the odd index means that we're just going to have, the answer here is going to be -1, -1, because we can find that the triple inside of here is going to be -1 times -1 times -1. When we have an even index and our radicand is negative, we get a situation that's an impossibility. Because what we're trying to say, what do we multiply by itself 4 times to get a -1? And the answer is, there is no answer, right? It is invalid. Okay, we can't do that because there's no way that a negative times a negative times a negative times a negative, we're never going to get a negative answer. So we have to be careful that when we have a negative radicand instead of an even index, we've got a big problem. And that's where it's saying right here in case 2, if the index is even and the radicand is negative, then our solution is not a real number. And we will cover these and talk about these in section 7. We will not be doing any graphing, so you can breeze through that part. And we will talk a little bit about what does it mean when we're taking like the square of a square root. If we're taking the square root of a square or the cube root of a cube, you know, what is that meaning? And if it's an even, if you're taking the square root of a square, we're always going to have the principal square root as the absolute value of the square. If we have an even, there's 2 cases here. If it's even, then it's the absolute value. If it's odd, it's that actual number. So I have a couple examples to show you here on that. So this is even. So if you have a negative and you're raising it to the same power that you have here in your index, you would think that the answer would be -5. But we're going to say that when you have an even, it's always going to be the absolute value. So our answer here is, in fact, 5. Here's another example where we're taking the index matches the exponent here. So you would think that the answer here would be the absolute value of the negative square root of 3. So it would be the absolute value, absolute value of -3. But notice that there's a leading negative here. So we're going to actually get an answer minus the absolute value of 3. Our answer is going to be 3. So when the negative is on the outside, we're going to apply that at the very end. Here's a case where I've got an odd index and I have a radicand, a number raised to that power. So the 5th root of -5 to the 5th power, since we have an odd here, but it matches, our final answer is going to be -5. So when we have an odd index, we in fact can leave the negative there. And I threw in this example as well. Here I have an m to the 8th, the 4th root of m to the 8th. And I want you to use what you know about exponents to rewrite this on the inside. This is really m squared to the 8th power, to the 4th power, because remember we just multiply these, and then you can see that, okay, I've got a 4 for my index, I've got a 4 for my exponent, so I'm going to rewrite this as minus m squared. Again, I'm applying the negative after I've done all the stuff inside. I hope that this helps you through section 7.1. Please reach out if you have any additional questions, and promise me that you'll practice these so you will be really efficient with them. Thank you. Look for the next video.